Deep within our solar system, at a staggering distance of approximately 880 million miles away from Earth, there exists a mesmerizing world that has fascinated astronomers for countless centuries. Welcome to the enigmatic realm of Saturn, the gas giant brimming with mysteries. From the uncannily artificial hexagonal pattern adorning its North Pole to the inexplicable phenomena of space-borne downpours, recent discoveries have raised concerns about the fate of Saturn's majestic rings. But why do astronomers believe these celestial wonders are on the brink of vanishing? And what are the enigmatic occurrences meandering through the Saturnian ring system? Our journey of unraveling the secrets of Saturn commenced with the first close-up images, captured by the Pioneer 11 spacecraft in 1979. However, it wasn't until the advent of the Cassini mission in 2004 that scientists truly embarked on a voyage to comprehend the hidden marvels of this ringed world. As our explorations of Saturn delve ever deeper, the planet continues to peel back its layers, revealing just how much remains shrouded in mystery. Saturn, the second largest planet in our solar system, conceals a core roughly half the radius of the planet itself. Astonishingly, this core weighs approximately 12 to 20 times the mass of our home planet, Earth. Yet what truly boggles the mind is Saturn's ethereal quality. It would gracefully float in a vast reservoir if we possessed one substantial enough to accommodate it. This peculiarity arises from Saturn's remarkably low density, an attribute that sets it apart as the least dense of all the planets within our solar neighborhood. While most planets that encircle our Sun assume near-perfect spherical forms, Saturn stands as an outlier. This gas giant rotates at a breakneck pace, causing it to bulge noticeably at its equator, while flattening considerably at its poles. Saturn's grandeur measures approximately 75,000 miles in diameter at its equator, extending roughly 68,000 miles from one pole to the other. Its distinct bands, painted in shades of yellow and gold, are observable from Earth and result from the tumultuous winds racing through its upper atmosphere at speeds reaching an astonishing 1,100 miles per hour. Yet perhaps the most captivating feature within Saturn's enigmatic repertoire is the colossal hexagonal pattern etched across its North Pole. This hexagon, with dimensions spanning approximately 20,000 miles in diameter, initially imparts the impression of a meticulously crafted megastructure, an aspect that only adds to the planet's aura of mystery. High-resolution imagery from Cassini's lenses has meticulously compiled a breathtaking animation, presenting this phenomenon in vibrant color for the very first time. Nestled within the swirling maelstrom of the hexagon, a monumental hurricane rages. Surpassing Earth's hurricanes by a staggering 50%, this colossal tempest reigns supreme. Crimson vortices, the vivid dancers of the celestial ballet, scatter themselves around the hurricane, harmonizing their dance steps with the counterclockwise rhythms of the hexagonal jet stream. Within the hexagon, a curious compositional contrast becomes apparent. Abundant smaller haze particles swirl within the hexagon's confines, while larger particles are a rarity. This resilient hexagon, unlike any other storm known to us, has endured the test of time, persisting for decades, perhaps even centuries. The genesis of this massive hexagonal storm is attributed to deep thermal convection, a captivating phenomenon where heat is transferred through the movement of fluid or gas, leading to atmospheric flows that spawn grand polar cyclones and an eastward jet pattern at higher latitudes. These atmospheric elements amalgamate in the upper reaches of Saturn, ultimately birthing the distinctive hexagonal shape that graces the planet's North Pole. The hexagons of Saturn stand as a testament to the extraordinary marvels our universe can conjure. Yet, Saturn continues to unfurl its portfolio of enigmatic features. Voyager's data unveiled mysterious spokes straddling the expanse of Saturn's rings. However, puzzlement ensued when the Cassini mission detected no signs of these ghostly apparitions. Intensive scrutiny revealed that these spokes tend to appear dark when observed from above, but adopt a luminous demeanor when observed from below. The precise origins of these perplexing streaks remain cloaked in uncertainty, but one fact remains indisputable. They reappear seasonally during Saturn's spring and fall. Saturn's ring system, the largest and most conspicuous among our solar system's repertoire, comprises 7 rings. These rings, initially discovered in the order of their proximity to Saturn's equator, stretch outward for a staggering distance. The outermost E-ring, spanning a distance of about 75,000 to 260,000 miles, is a standout among them. Saturn's rings, despite their grandeur, exhibit an astonishing flatness. Meticulous observations reveal that specific segments within the rings can boast a thickness of roughly 0.6 miles, while the principal rings merely measure a scant 32 feet in thickness. Diversity thrives among the particles inhabiting Saturn's rings. These particles, predominantly composed of water ice, span a vast spectrum, ranging from minute icy grains resembling the finest dust to substantial fragments akin in size to residential houses. An exceptional few particles even attain dimensions reminiscent of towering mountains. However, our understanding of Saturn's rings has journeyed a considerable distance from its humble origins. Nearly 4 centuries ago, when Galileo first directed his telescope toward Saturn, he described the gas giant as possessing ears, or handles. In truth, these elongated bulges, now understood as Saturn's rings, eluded Galileo's grasp due to the limitations of his modest telescope. Fast forward to today, and our comprehension of Saturn's rings has transcended those early misconceptions. We now understand that these celestial rings, chiefly composed of water ice, exist in a delicate equilibrium. They are torn between Saturn's gravitational pull, which beckons them toward the planet, and their orbital velocity, compelling them to spiral outward into the void of space. Astonishingly, Saturn did not always possess this awe-inspiring ring system. For more than 90% of its existence, Saturn dwelled in the absence of these celestial adornments. The origins of Saturn's rings remain an object of fascination and ongoing debate. One possibility is that these rings materialized later in Saturn's existence, emerging from the collisions between small icy moons orbiting the gas giant. Such collisions might have been instigated by the gravitational perturbations induced by the passage of asteroids or comets. Another captivating theory posits that Saturn's rings could be the remnants of dwarf planets that met their end in the distant past, now living on as the enigmatic rings that grace Saturn's expanse. Recent studies place the age of Saturn's rings at approximately 100 to 400 million years, hinting at the possibility of a transient celestial beauty destined to fade away. The majestic rings of Saturn, as awe-inspiring as they are under siege by a celestial force that threatens their existence. In another 100 million years or so, these resplendent rings may succumb to the relentless influence of the sun's radiation and the plasma clouds birthed by the impact of space rocks. One pivotal contributor to the depletion of Saturn's rings is the phenomenon known as ring rain. In this process, the dust particles populating Saturn's rings, when electrically charged and perturbed, gravitate towards Saturn's magnetic field. This magnetic embrace draws them inward toward the gas giant's upper atmosphere, where they begin a celestial descent. As these particles cascade through the atmosphere, they transfer their accumulated energy to their surroundings, leading to Saturn's atmospheric heating. The ring rain is a cocktail of chemical compounds, including organic ones. It encompasses water, butane, propane, methane, ammonia, carbon monoxide, carbon dioxide, and molecular nitrogen. Over time, this mixture could contribute to alterations in the composition of Saturn's atmosphere. While this alone may not suffice to foster life on Saturn, it beckons questions about the habitability of Saturn's moons, particularly Titan and Enceladus. Titan, Saturn's beguiling moon, boasts a thick atmosphere rich in organic molecules, including complex hydrocarbons that are regarded as the building blocks of life. Although the extreme cold of Titan, with temperatures plummeting to approximately -290 degrees Fahrenheit, would likely thwart life as we know it, scientists have put forth an intriguing hypothesis involving a molecule called acrylonitrile. Acrylonitrile exhibits a unique characteristic. It is potentially capable of forming stable and flexible structures resembling cell membranes. These thin, sheet-like structures, akin to lipid bilayers, could transform into small hollow spheres known as exosomes, serving as microscopic containers for storage and transportation purposes. What adds to the intrigue is the presence of significant amounts of acrylonitrile molecules in Titan's atmosphere, detected by the ALMA observatory, up to 2.8 parts per billion. The abundance of acrylonitrile suggests that Titan's largest lake, Ligeia Mare, could have accumulated enough of this chemical to generate approximately 10 million exosomes in every milliliter of its liquid. To put this into perspective, it surpasses the abundance of approximately 1 million bacteria per milliliter of coastal ocean water on Earth. The presence of acrylonitrile sparks new possibilities for the existence of unique forms of life within Titan's enigmatic realm. Beyond Titan, Saturn's moon Enceladus emerges as another captivating celestial body. Beneath its icy exterior, Enceladus hides a subsurface ocean of liquid water, making it a compelling candidate for the presence of life or the conditions conducive to its emergence. Enceladus propels icy jets of water into space from this subterranean ocean. Some of these icy particles are swayed by Saturn's magnetic field and gravitational forces, causing them to rain down onto the gas giant's atmosphere. This phenomenon, referred to as moon rain, adds to the cosmic drama unfolding around Saturn. Saturn's ring rain constitutes a complex cocktail of chemicals, including organic compounds, and has the potential to reshape the composition of Saturn's atmosphere over time. While these transformations alone may not pave the way for the emergence of life on Saturn, they cast intriguing possibilities regarding the habitability of Saturn's moons. Recent revelations have led to a surge in Saturn's moon count, tallying up to 145 moons. Two of these moons, Titan and Enceladus, emerge as particularly captivating contenders for hosting conditions that could support life. Titan, renowned for its thick atmosphere and a wealth of organic molecules, presents an alluring canvas for the search for extraterrestrial life. Rivers, lakes, and seas grace its surface, albeit containing methane and ethane rather than water. While the extremities of Titan's conditions, such as temperatures plummeting to approximately -290 degrees Fahrenheit, render it inhospitable to terrestrial life, scientists have advanced an alternative hypothesis centered around acrylonitrile, a molecule capable of forming structures resembling cell membranes. This molecule could usher in a novel paradigm, enabling the emergence of life in an unconventional manner. Enceladus, with its concealed subsurface ocean, stands as another compelling celestial body. It expels jets of water ice into space from this hidden ocean, offering tantalizing glimpses into the potential for subsurface oceans to harbor life or the requisite conditions for its inception. As we look ahead, the launch of NASA's Dragonfly drone, scheduled for 2027, promises to delve deeper into the mysteries of Titan and the potential for life in these uncharted realms. In the realm of discovery, Saturn continuously astonishes and pushes the boundaries of our understanding. While the fate of its iconic rings hangs in the balance, the allure of its moons, particularly Titan and Enceladus, beckons us to probe further into the enigmatic possibilities that await us within our own solar system. As we anticipate new revelations, stay tuned for the latest updates on our cosmic explorations. We hope you have enjoyed this expansive exploration of the wonders of Saturn and its celestial companions.